I wrote this down. ax squared plus bx plus c equals 0. What could this represent right here? What could this represent? That's a quadratic. Or what could, yeah, let's go bigger. What could it represent? That is a quadratic. Which quadratic could it represent? Which quadratic equation could it represent?
Cubes.
There are no cubes up there.
That's what I meant.
Which specific quadratic equation could it represent? Think bigger. Yes, right there. It could represent any of them. How many different quadratic equations are there?
A lot.
Use better language. There's an infinite number of quadratic equations. Which values do you change to get different quadratic equations up there? Which ones? A, B, or C. X is a variable. A, B, and C are any real numbers, any constants, any real numbers. So this represents all quadratic equations. Can you always set it to 0 if you need to?
Yeah.
Yes. All quadratic equations. Nice. Okay. So let's go for a little story time. And your job, you have two jobs. Make sure I don't make any mistakes, and also to understand each piece. So we're going to have a story here, and it's important that you just understand each step. That's it. That's all I'm asking you to do. Could I subtract c from both sides if I wanted to? Sure. Be ax squared plus bx equals what? Negative c. That's fine. Could I, if I wanted to, divide everything by a if I wanted to? But remember, I have to divide everything by a, right? So if I divide everything by a, I'm going to end up with x squared plus b over a x equals negative c over a. Are you with me so far? Are you with? Yeah. Again, I have not told you why we're doing this, but my question is, do you understand each of the steps I've taken so far?
Yes.
Okay. Yes, Chris. If I wanted to, could I add 7 to both sides if I wanted to? Because you can add, as long as you, not probably, definitely. If the scales are equal and I add the same thing to both sides, are the scales still equal?
Yeah.
Yes. So theoretically, I could add anything I want to both sides as long as I add the same thing to what? To both sides. Again, I have not told you the reason I am taking you on this little story time journey, but just bear with me, okay? So what I'm going to do here is I'm going to make some space, and we still have the same thing on both sides. I'm going to make some space. Negative c over a. So I'm just going to add, and it's going to seem really, really weird, but I'm going to add this. b over 2a squared. If I add that to the left side, where do I also have to put it? I have to put it on the right-hand side. b over 2a squared. So my question is, if my first statement is valid, which it is, it can represent any quadratic, is this statement valid as well?
Yeah.
I haven't done anything illegal. I haven't divided by 0. I haven't taken the square root of a negative number. I haven't added 5 and added 7 to the other side. We're still okay. We still have a true statement. Now, it seems strange. Like, why would we want to make it look worse, right? Because let's be honest. Does that look better or worse than what we started with? It looks worse. It does look worse. So I'm going to write something down here, and you're going to help me for a second here. If I write this down, what does it mean to square something? Multiply by itself. So this means x plus what? B over 2a times x plus b over 2a. So this is just a sidebar, okay? If I were to multiply that out on the right-hand side, what is x times x? X squared. And then I multiply x times this, and it would be x times b over 2a plus, I'm going to do the same thing right here, x times what? B over 2a, and then what do I have here? B over, sorry, it's freaking out just a little bit. B over 2a squared. Let's do a little bit of algebra here to clean this up. We have the same thing in here, so how many do we have? 2 of them. So we have x squared plus 2x b over, oh, and I'm almost writing, it's b over 2a plus what? B over 2a squared. We're going to leave it like this. I'm being very particular about when I'm multiplying and when I'm not, so just bear with me. What does this 2 cancel with? The 2 in the numerator, where does that cancel with? The 2 in the denominator. So what am I left with? X squared plus
X times
b over a times what? x, and I'm not going to multiply this out. B over what? 2a squared. Hey, have you seen that before? Where do you see that?
On the left.
On the left, right here. So, no questions yet. This right here, where is that?
Up in the left.
It's right here. So what does this equal?
Each other.
Those two things are the same. This thing we've shown this is the same, but what does this equal? This thing right here. We have now shown everybody, we showed that this is equal to this, right? We did a bunch of algebra, and what does this actually equal? It equals this thing, but what is this equal to right here? The same thing up there. So what does this thing in the red box equal? This thing in the red box. This thing in the red box equals this thing in the red box. That's the big step right here. That's the big step. This red box, and where are we going to put it? Right there. So what do we end up with now? We end up with 2a squared in parentheses, right? So we end up with x plus b over 2a what? Squared equals, what's on the left still?
Negative c over a.
Negative c over a plus what? B over 2a squared. So this is where we're going to pause for a second. So again, it looks a little better than where we were before, but still, does it look as nice as what we started with? You might be asking yourself, what's the point? And I hope you are. Let's get to the point. Let's see what's going on here. Okay. Let's clean up the right-hand side just a little bit, okay? Is that okay? Can we clean up the right-hand side a little bit? What's the one operation we can do on the right-hand side? Yeah, specifically the square, right? So what's it going to be? B squared over what? 4a squared. If we have two fractions and we want to add them, what do we have to do to both of them? Or what do we have to find? We have to get a, if I can actually circle this, get a common denominator. What do we multiply this by to get a common denominator? 4a over 4a. Because we need 4a squared in the denominator. So what does that become? Negative what? 4ac over what? 4a squared plus b squared over 4a squared. So does that do we now have a common denominator?
Yeah.
Yep. So what's that going to be? I'm going to reverse it here. It's going to be b squared minus what? 4ac all over what? 4a squared. So let's just rewrite it again. So what do we have here? X plus b over 2a squared equals b squared minus 4ac all over 4a. And you might be further doubting me because you're thinking to yourself, why is he doing this? What's the point? What's the point? What is the point? If you suddenly have an epiphany and understand what the point is, keep it to yourself. Let's have people come to it on their own. So right here, what do we have on the left? We have a square. How could we get rid of a square? Nope, not that's what a square is. What do we do to get rid of a square? Square root. Side note, what's the square root of 9? And if I add in a square root, you have to do plus or minus. If I ask you what times itself equals 9, there are two answers. So if I square root both sides, what happens to the left? It just becomes x plus b over 2a. But over here we have plus or minus the square root of this. Wait, hold on a sec. Just wait a sec. Hold on a sec.
Yeah.
So if we have the square root of a fraction, that's the same thing as doing the square root of the top and the square root of the. And just as a side note, when you have plus or minus, do you have to have both plus or minus on the top and bottom? No, you don't. Plus or minus the top over plus or minus the bottom is the same thing as just one plus or minus. What's the square root of 4a squared? B squared minus 4ac all over what? 2a. Well, that's kind of nice. So let's just summarize what we now know. We now know that x plus b over 2a is equal to what? Plus or minus the square root of? B squared minus 4ac all over 2a. Okay. If we want to, let's say, isolate x, what should we subtract from both sides? X equals negative b over 2a plus or minus what? B squared minus 4ac over 2. Hey, do we have a common denominator?
Yep.
So what do we end up with? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Has anybody seen this before. If you want to use the quadratic equation, you might ask yourself, is that easily factorable? And no, it's not. It doesn't really look like it. What does A equal in this one? 1. If it was 0, then there would be no x squared. What's the invisible number right there? 1. So what does B equal? 7. And what does C equal? -3. So then you plug this in. I am going to start you off with the proper behavior right now. Don't just plug it all into that formula. Do you see the thing underneath the square root sign? What's the thing underneath the square root sign? B squared minus 4AC. Does anybody know what that's called? You might know what this is called. This has a special name. It's called the discriminant. What you want to do is, instead of having to write the whole fraction, the whole fraction, the whole fraction, you're going to spend most of your time there. So just do that first. What is B squared? Well, that's going to be 7 squared minus 4 times 1 times -3. So this is going to be 49 plus what? 12, which is, what is it? 61. So what is x going to be equal to? Negative b. What's b? -7 plus or minus the square root of 61 all over 2 times 1, 2a. So what is it? Just 2. That right there, is that an integer? Yeah. The square root of 61 is not an integer. So is the whole thing an integer? No, it's not. When you get an answer like that, that will tell you something about the factoring. Do you think that tells you the factoring is easy or the factoring is hard or the pretty not cool? Because if that's the zeros, you don't want to have to factor that out. But look, how long did that take? Like 10 seconds, right? But what should you do first? I guess if the one small thing you take away from this class, the discriminant. I've seen it happen so many times where kids write like fraction, and then they write another fraction, and they write another fraction where they're only changing one little thing. Just do the little thing first, and then write it down. Quadratic formula can always be used with any quadratic of the form ax squared plus bx plus c equals 0. What do you think are the easy ways to use the quadratic equation? Create right there, right in the middle of the work. What did we create? We created the square. Do you remember when we added this thing? What did you think when I added b over 2a squared to both sides? Be honest, what did you think?
Suspicious.
Totally random. It seemed totally random, right? But why did I add this? Because this was the perfect thing to add to turn it into a square. This is the kind of thing where someone was like, oh man, I really want to make it a square, so I'll add it. So then we did it. I knew what we were looking for, so I added what we were looking for. This is kind of like an example of reverse planning.
Yeah.
The craziest proofs you will see in math, do that. You're going along, and all of a sudden your teacher is going to be like, and now we're going to blah, 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 blah. And you're going to be like, where did that come from, right? I saw some proofs when I was studying abroad in Hungary and Budapest, where the professor would show us like a 7-line proof, and it was like the coolest thing ever. But they're like between steps 2 and 3 and 4 and 5 would be totally random math, and you would understand it, and it would work at the end beautifully, and you'd be like, what the heck? And then the professor would literally say like, what they don't, and they had these great Cookie Monster accents, because the Hungarians have these fantastic accents. It took him 9 years to see this, you know? So just because something is straightforward and simple does not mean it was easy to see. Absolutely does not mean it was easy to see at all, at all, at all. You were doing this. What do you have to do first?
Discriminant.
Yep, but what do you have to find before you find the discriminant? So in this one, what does A equal?
6.
What does B equal?
2.
And what does C equal? -4. Exactly. So what do you then find the discriminant for 1 here? So that's going to be b squared minus 4ac. So that's going to be 2 squared minus 4 times 6 times what? -4, which is going to be 4 plus 16 times 6. So what's that going to be?
100.
It's going to be 100. So therefore, it's going to be x equals -b. So it's -2 plus or minus what? 100 all over what? 12. 2 times 6 is 12. Can you simplify that? Yes, that's going to be -2 plus or minus 10 over 12. So can you figure out what the actual two numbers are? Yeah, it's -2 plus 10 over 12, or what? -2 minus 10 over 12. So that's going to be, what's -2 plus 10?
8 over 12.
So it's 8 over 12, which is 2/3. And this, what's -2 minus 10? -12. So what's that going to be? So how many answers did we find? 2. And did we actually find the actual totally simplified fractions? Yeah. Yeah. Does that sometimes work? -1. Someone else, not Chris. Can you tell me what b is equal to on the second one? 1. And be careful, what's c equal to?
2.
2. Why is c equal to 2 on the second one? 9 minus 7 is 2. It has to equal 0. Correct. Nice. Well, there's 0 over there already.
Oh, it is 6 minus 0.
Oh, that there. Hey, we fixed it. Yeah. Okay. What about 3? We're not going to do the second one now, but for the third one, what do you have to do first on this one in order to get the a, b, and c values? Subtract 5. So what do you end up with?
0 equals negative x squared plus 2x minus 5.
So what does a equal in this case?
Negative 1.
What does b equal? 2. And what does c equal? Negative 5. Then b over 2a squared. That is what you add to both sides to do what? To complete the square. That's the thing you add to both sides to complete the square. That's what you add to both sides to complete the square. So, will you be asked to actually complete the square on some of the homework assignments tonight? Absolutely. There's great examples in the book that will lead you through it.